video, we are going to discuss Polynomial chapter, do this and try these problems. Before discussing, we will take a small example, 2x square plus 3x plus 7. In this expression, we have coefficients. The coefficients are 2 and 3. Variables, here the variables of this expression is x and the power. Power of x is 2 and the power of x here is 1, and also we have constant. So this expression to be a polynomial, it has to satisfy a certain property, and the property is the power of a variable should be a positive integer. This is very important, students. If you understand this, rest of the chapter will become very easy for you. The power, here we have both power, here power of x is 2, here power of x is 1. If the power of the variable is a positive integer, positive means plus 2 or plus 1 or plus 3, then this expression is a polynomial, else it is not. So the page number, I will discuss page number 52, do these problems. State which of the following are polynomials and which are not. First one, 2x cube. 2x cube is a polynomial because the power of a variable x is a positive number, positive integer. 3 is a positive integer, therefore it is a polynomial. Second one, 1 by x minus 1. 1 by x can be represented as x to the power of minus 1 minus 1. Now see, students, that power of a variable x is a negative integer. It is not a positive integer. Therefore, it is not a polynomial. Third one, 4z square plus 17. It is a polynomial because the power of z, polynomial z is a positive integer, 2 is a positive integer, therefore it is a polynomial. Fourth one, m square minus root 2m plus 2. It is a polynomial because the power of m here it is 2 and the power of m here it is 1. Both are positive integers, therefore the given expression is a polynomial. P to the power of minus 2 plus 1 is not a polynomial. You can guess, students, because the degree or the exponent of the variable p is not a positive number. It is a negative integer. Therefore, it is not a polynomial. Page number 52, try this. Write three different quadratic, cubic and two linear polynomials with different number of terms. Quadratic polynomial is a polynomial if the degree of the variable or degree of an expression is 2, then it is said to be quadratic polynomial. If you observe all the three examples, the number of terms may be different, but the degree or highest power in the three example is 2. Therefore, it is said to be a quadratic polynomial. Cubic polynomial is a polynomial if the degree of a expression is 3. Degree means highest power. If the highest power of a variable is 3, then it is said to be a cubic polynomial. In the three examples, if you notice clearly, all the three examples have three different variables, but degrees remain same. So these are the examples of a cubic polynomial. Linear polynomial is a polynomial if the degree of a variable is 1. If there is no power, it means 1. Page number 53, try this problem. First one, write the general form of a quadratic polynomial and a cubic polynomial with variable x. The general form of a quadratic polynomial is ax square plus bx plus c, where a is not equal to 0. This is the one of the important condition. If degree is 2, then it is a quadratic polynomial. General form of a cubic polynomial is ax cube plus bx square plus cx plus d, where a should not be equal to 0. So the degree of a polynomial is 3, then it is called a cubic polynomial. Second one, write the general polynomial qz of degree n with quotient b0, b1, b2, so on bn. What are the conditions on b0, b1, b2, so on bn? Q of z is a polynomial, b0 z power of n, b0 is a quotient and z power of n is a variable, b1 z power of n minus 1, b2 z power of n minus 2, so on bn minus 1 z plus bn. It is a polynomial of n degree and the condition here is b0 should not be equal to 0. Do this first one. If p of x is equal to x square minus 5x minus 6, then find the value of p of 1, p of 2, so on p of minus 3. So given p of x is equal to x square minus 5x minus 6. So we have to find p of 1, first one. So wherever there is x, we have to replace the value 1 in the place of x. So P of x is x square minus 5x minus 6. So P of 1 will be 1 square minus 5 times 1 minus 6. 1 square is 1, 5 times 1 is 5 minus 6. So we have to add all the negatives. Minus 5 minus 6 is minus 11, plus 1 minus 11 value is minus 10. So the value of P of 1 is minus 10. Similarly, P of 2 to P of minus 3 values and the procedure is given below. Please go through it once. Second one, it is a similar procedure. It is a polynomial with m variable. P of m is given as m square minus 3m plus 1. So we have to find P of 1. So wherever there is 1 m, we have to replace with 1 students. So m square means 1 square minus 3 into 1 plus 1. 1 square value is 1, 3 times 1 is 3 plus 1. So we have to add all the positive numbers and negative numbers. 1 plus 1 is 2, 2 minus 3 is minus 1. So therefore P of 1 value is minus 1 for the polynomial m square minus 3m plus 1. So we have to also find P of minus 1. In the place of m, we have to replace minus 1. Earlier we have replaced it with plus 1. Now we are going to replace with minus 1. So I'm just going to change the pen color. So 1 square, sorry, minus 1 square minus 3 into minus 1 plus 1. Minus 1 square value is plus 1 because minus 1 into minus 1 is plus 1. Minus into minus is plus, 3 times 1 is 3 plus 1. So all are positive numbers, so we can add up. 1 plus 3 is 4, 4 plus 1 is 5. So the value of P of minus 1 for the polynomial n square minus 3m plus 1 is 5. Do this first one. P of x is equal to x square minus 4x plus 3. Find the value of P of 0, P of 1, P of 2, P of 3 and obtain the zeros of the polynomial P of x. So P of x is x square minus 4x plus 3. P of 0 will be plus 3. P of 1, we have to replace the value of 1 in the polynomial x square minus 4x plus 3 and the value is 0. P of 2 value is minus 1. P of 3 value is 0. Clearly P of 1 and P of 3, the result is 0. Therefore 1 and 3 are zeros of the polynomial. The reason 1 and 3 are zeros of the polynomial because after replacing 1 and 3, the answer is 0. Therefore 1 and 3 are zeros of the polynomial P of x. Second one, check whether minus 3 and plus 3 are the zeros of the polynomial x square minus 9. Given P of x is x square minus 9. We have to replace minus 3 in the place of x. After replacing minus 3 in x, if our result is 0, then this value minus 3 will be the 0 of the polynomial. Let's see whether our result is 0 or not. P of x is x square minus 9. P of minus 3 will be P of minus 3 whole square minus 9. Minus 3 square will be 9 minus 9. Reason is minus 3 square can be written as minus 3 into minus 3. Minus into minus is plus, 3 3s are 9. Though minus is there, for square the result will be positive 9. Plus 9 minus 9 is 0. Therefore minus 3 is 0 of the polynomial. Also we have to check with plus 3. So P of x is x square minus 9 and P of 3 will become 3 square minus 9. 3 square value is 9, 9 minus 9 is 0. Therefore 3 is also 0 of the polynomial. So in this question both minus 3 and plus 3 are zeros of polynomials. We'll move to the next topic in the polynomial chapter, that is graphical representation of polynomials. We have three polynomials: linear polynomial, quadratic polynomial and cubic polynomial. I have taken example for each. The linear polynomial in graph is nothing but a straight line. Remember this, students. Always the linear polynomial with degree 1, it is a straight line. Quadratic polynomial in graph, it is a parabola. The picture what you are seeing on the screen, we call it as parabola. Parabola. And the cubic polynomial is a curve in the graph. Always linear polynomial straight line, quadratic polynomial is a parabola and cubic polynomial are curve. So the zeros of the polynomial for each polynomial is nothing but the straight line or parabola or curve meeting the x-axis. Wherever it is meeting at x-axis, that particular point is called zero of the polynomial. Here linear polynomial, the straight line is meeting the x-axis. We have to consider only x-axis, students, at minus 2. Therefore minus 2 is the zero of the polynomial. The quadratic polynomial, this parabola is touching the x-axis at minus 1 and also 4. So minus 1 and 4 are zeros of the polynomial x square minus 3x plus 4. Sorry, minus 4. This cubic polynomial is meeting the x-axis at minus 2, 0 and plus 2. Therefore minus 2, 0 and plus 2 are zeros of the cubic polynomial. So at most we have one zero of the polynomial for linear polynomial and two zeros for quadratic polynomial and three zeros for cubic polynomial, because this curve is meeting at 3 point. Maximum it can be 2 or 1, but at most it will have three zeros for cubic polynomial. At most it has two zeros for quadratic polynomial. We can see in the picture it is meeting at minus 1 and 4. Therefore it has at most two zeros for quadratic polynomial, and for linear polynomial we have only one zero. Do this. Draw the graph of y is equal to 2x plus 5, y is equal to 2x minus 5, and y is equal to 2x. And also find the zeros of the polynomial. So all these are linear polynomials, and we know that linear polynomials are straight line in the graph. So to do the graph, we have to take the truth tables like this: x-axis, y-axis, and if I take x0, y is 5, 0, 5 is the point, and x is 1, y is 7, 1 7 is the point. So 0 comma 5 lies here, 1 comma 7 lies somewhere here. So this is the straight line touching the 2 points, and y is equal to 2x minus 5 is the graph which looks like this, and y is equal to 2x are the point which passes through origin. So they're asking to find the zeros of the polynomial. Zeros of the polynomial are nothing but the straight line where it is meeting the x-axis. So it is meeting the x-axis at minus 2.5. So for minus 2.5 is the zero of the polynomial. And moving on to the zero of the polynomial for y is equal to 2x minus 5. This straight line is meeting the x-axis at 2.5 comma 0. Therefore 2.5 is the zero of the polynomial. And y is equal to 2x, this straight line is meeting the x-axis at 0. Therefore 0 is the zero of the polynomial. Try this. Write the three quadratic polynomials that have two zeros each. So the three quadratic polynomials that have two zeros each are x square minus 9, x square minus x minus 6, x square minus 3x minus 4. For this polynomial, two zeros are minus 3 and plus 3. For this polynomial, x square minus x minus 6 are minus 2 and 3. And the two zeros for this quadratic polynomial are minus 1 and 4. Second one, write one quadratic polynomial that has one zero. So y is equal to x square minus 6x plus 9 is a quadratic polynomial, and that one zero is 3. How will you verify that if a quadratic polynomial has only one zero? If it has only one zero, the graph should touch x-axis at only one point. Fourth question, write three quadratic polynomials that have no zeros. So the quadratic polynomial that have no zeros are 2x square minus 4x plus 5, minus 3x square plus 2x minus 1, x square minus 2x plus 4. All these three polynomials have no zeros. Think and discuss. Observe the curves in the graph given below. They represent y is equal to half x square, y is equal to x square, and y is equal to 2x square. Comment on your observation. Also plot some more graphs with y is equal to x square plus 1, y is equal to 2x square plus 1. If you observe carefully, students, y is equal to half x square is a parabola, y is equal to x square is also a parabola, and y is equal to 2x square is also a parabola. All these parabolas are passing through origin. So that is what we observed from the given three quadratic polynomials. They are also asking to plot some more graphs, but these two graphs will not pass through origin. Do this. Find the zeros of the quadratic polynomial given below. Also find the sum and product of the zeros and verify the relationship, the quotients of terms of the polynomial. First one, p of x is equal to x square minus x minus 6. So this is one of the important concept in this chapter, students. Relationship problem is must for the board exam. One question they will ask for the board exam. So to find the relation between zeros and quotient, first we have to find the zeros of the polynomial. So polynomial is x square minus x minus 6 is the quadratic polynomial. So we have to split the middle term minus 1. So minus 1 can be expressed as minus 3 plus 2, which is minus 1. So x common in the first two term x minus 3, and 2 common in the next two terms x minus 3. X minus 3 is common in both the cases, so x plus 2. So we have to equate with 0 because we have to get the zeros of the polynomial. X minus 3 should be equated with 0 and x plus 2 should be equated with 0. Minus 3 goes to that side, so x is equal to 3, plus 2 goes to that side, x is equal to minus 2. So zeros are plus 3 and minus 2. To find the relation between the zeros and quotient, we have to keep in mind two things, students. We have to use sum of zeros and product of zeros. So we should not use the formula, but in fact we have to derive the formula. So sum of the zeros, the two zeros are 3 and minus 2. Sum means 3 plus minus 2. These are the two zeros. So 3 plus minus 2 is 3 minus 2, which is 1. Minus of minus 1 by 1. Minus of minus 1 is plus 1. 1 by 1 is nothing but 1 itself. So we have to rewrite this 1 in such a way we have to get the formula minus b by a. So here minus as it is minus, and minus 1 is nothing but b here. So a here 1, b is minus 1, and c is 6. So minus of minus 1 by 1 can be represented as minus b by a, which is nothing but minus quotient of x by quotient of x square. Product of zeros, product means multiplication. We have to multiply the zeros. Our two zeros are 3 and minus 2. 3 into minus 2 is minus 6. We have to write minus 6 in such a way we have to get in the formula way. So minus 6 by 1 is nothing but c by a, which is nothing but constant by quotient of x square. Similarly, you have to find the other three problems, students. Have a try. We'll discuss try this. Find the quadratic polynomial with zeros minus 2 and 1 by 3. To find the quadratic polynomial, we have to use the formula x square minus sum of zeros into x plus product of zeros is the formula to find the quadratic polynomial. So here they have given zeros. The two zeros are minus 2 and 1 by 3. So sum means we have to add the zeros. Product means we have to multiply these two zeros. Let's do that one. X square minus sum. Sum means addition. In formula minus is there. Sum of zeros. 1 0 is minus 2. And plus I am doing because we have to do sum. Other 0 is 1 by 3. Plus product of zeros means product means multiplication. The two zeros should be multiplied minus 2 and 1 by 3. So it can be represented as x square minus 2 plus 1 by 3 is nothing but minus 5 by 3, and plus into minus is minus 2 into 1 by 3 is 2 by 3. So this can be written as, I forgot to mention x here, students. So minus into minus is plus 5 by 3x minus 2 by 3 is a quadratic polynomial with zeros minus 2 and 1 by 3. Second one, what is a quadratic polynomial for the sum of zeros is minus 3 by 2 and product of zeros is minus 1. The difference between first one and second one, students, here zeros are given, and the second one they have given sum of 0 and product of zeros. Now same formula we will use. The form quadratic polynomial is x square minus sum of zeros into x plus product of zeros. So x square minus sum. Sum is minus 3 by 2. I am replacing as it is minus 3 by 2 into x. Product is minus 1. I am replacing as it is. In the previous problem, we have added sum means addition of two zeros we have added, but here in this case we are not adding because directly they have given some value which is minus 3 by 2. Formula minus I am writing as it is, some value minus 3 by 2 I am writing as it is. So don't get confused, students. And plus product is given as minus 1. I am replacing product value as it is. Moving on to the next step, x square minus into minus is plus 3 by 2x plus into minus is minus 1. So this is the quadratic polynomial with sum minus 3 by 2 and product minus 1. Last concept in this chapter, do this if alpha, beta, gamma are the zeros of the given cubic polynomials. All these are cubic polynomials. We have to find the sum of zeros, sum and product zeros and product of zeros. So we have a formulas for this. Sum of zeros is minus b by a, sum product of zeros is c by a, and product of zeros is minus d by a, where a, b, c, d are quotients of the given polynomial. Here sum of zeros is minus b by a. I will write minus in the formula. B is 3 and a is 1. So minus 3 by 1 value is nothing but minus 3. Sum product formula is c by a. In the given expression, c is minus 1 and a is 1. So minus 1 by 1 is minus 1 itself. Product of zeros formula is minus d by a. So I will write minus d by a. D is 2, here minus of minus 2 by a is 1. So answer is plus 2. Second one, same formula, minus b by a. B is 8, so minus 8 by 4, which is nothing but minus 2. C by a, C is minus 6, A is 4, so minus 3 by 2. Minus D by A, D is minus 2, minus into minus is plus 2 by 4, which is nothing but 1 by 2. Values for the given as cubic polynomial. Thank you for watching, students.